And we're back looking this time at the volume of a cone. So the formula for the volume of the cone, cylinders are three-dimensional figures with one circular base. The distance perpendicular, meaning 90 degrees. You'll notice this is a 90-degree angle. It says from the height to the vertex. I apologize. It's supposed to say from the base to the vertex is called the height. My apologies for that little typo on there. And again, just like in the cylinder, it does not matter that it is which way it is oriented. If the base is on the bottom, the height is still perpendicular from the base to the vertex. And if it's on its side, again, the height is perpendicular from the base to the vertex. This distance from the circular base, from the side of the circular base that is not perpendicular, that goes up to the vertex, is called the slant height, and you use that for other measurements. So the formula in class, we took our cone and we filled it with water and we guess to see how many times it would fill up the cylinder. And we found that it takes, with a cone and a cylinder that have the same height and the same base. That is very important. They must have the same height and the same base. But if they have the same height and the same base, it takes 3 cones to fill up a cylinder. If you have not seen that demonstration, I highly recommend that you look for the water demo of a cone to a cylinder for the formula. It is very powerful to see that. And we did that live here in class. So this is for those of you that were home and did not see that. It does take 3 cones to fill up a cylinder. Therefore, we start with the volume of a cylinder formula. The volume of a cylinder formula is pi r squared h. And then we multiply it by 1/3 or divide it by 3. Because remember, taking 1/3 of something, multiplying it by 1/3 is the same exact process as dividing by 3. So we have 2 different ways of writing the formula. One is 1/3 pi r squared h, and the other one is pi r squared h divided by 3. So we're going to practice finding the volume of a cone. Let's say that we are given a radius of 3 units. Again, that just because I like to draw it out this way. If that's 3 units, this is 3 units, and our diameter is 6 units. I just like to have the diameter and the radius both marked. That's just personal preference. And if that's 3, that's 3. Let's say that our height must be approximately 12 units. So we're going to start with our formula. Volume is equal to, now again, we can write 1/3 pi r squared h, or we could write pi r squared h divided by 3. My personal preference is to write the fraction in that manner. But remember, 1 times pi times radius squared times height, and the whole thing is divided by 3 is the exact same process. So I'm going to start with this formula, this version of the formula. So pi times radius squared. So I like to expand that radius squared out, radius times radius, times height, divide by 3. Remember, pi is a constant, 3 is a constant. So I'm going to write my constants in there, and I'm going to leave space for my variables that stand for the dimensions here. So my first variable was an r, standing for the dimension of radius. My radius was 3, so I'm going to put it in twice because remember, it is to the second power. And then my second dimension that my formula is calling for is the height. My height is right here, and we have marked it as 12 units. And remember, this is units multiplied by units, but I know that my final answer is going to be units to the third power because I'm multiplying units times units times units. And so our next step then is to go ahead and multiply this out. I personally like to simplify before I multiply. 3 divided by 3 is 1, and so that's going to be 1. 3 times 12 is 36. And I get a value of 36 pi units to the third power. If I had not divided first, I would have had 3 times 3 being 9, 9 times 12, of course, and then we would be dividing by 3. For those of you who like to see that algorithm, 9 times 12, if you're not doing that in your head, is going to be 108 divided by 3. And again, if you don't enjoy dividing that in your head, 108 divided by 3 using my standard algorithm is, of course, 36. So I still get my 36. That's why I like to simplify before I multiply. Of course, I could have also simplified something else. I could have simplified 12 divided 3 and gotten 4, and then it would have been 3 times 3 times 4, which would have been 9 times 4 being 36. So it's up to you which order you multiply in, as long as you multiply all of those together. And we have 36 pi. I personally, I like leaving things in terms of pi because it is an exact answer, but a lot of people, most people in fact, would probably prefer to estimate out 36, multiply it out by pi. You can, of course, take our standard approximation of pi, which is 3.14, multiply it by the 36 and get your approximation. But again, I like to use the most accurate approximation I can, just like I did in the last video. And so I'm going to multiply 36 by a more accurate version of pi by using my pi symbol on my Desmos calculator here. 36 times pi is approximately 113.097. So I'm going to write 113.10 or 113 and 10 and 1/10, my apologies. If I had multiplied by the less accurate approximation of pi, multiplying it by 3.14, which is what we're used to, see how my answer is very, very, very similar. This is just a slightly more accurate estimate of pi because I used more digits to multiply by pi. All right, so again, you take your volume of a cone, you take your radius times height, multiply it by pi, and divide by 3. Again, you can do that in any order. So you can actually write in, you can multiply pi times 3 times 3 times 12, and then take the whole thing and divide by 3. I do want to show that you can do that. So as long as you are good writing that formula out, if you can use it in formula notation, I can, of course, just type it in the way I see it. Pi times radius times height, and the whole thing divided by 3. You'll notice that I get the exact same answer because order of operations is going to kick in, and it's going to multiply all of those and divide by 3, and we get 113.09 or 113.10. I hope this was helpful. I hope I didn't talk too much in that video, and I'm going to write that down. 113.10 units to the third power. And again, I went from equals to approximately equals because once I multiply by my irrational, that is no longer completely 100% exact. It is an approximation. And so that is my approximation of the volume of this cone. Radius times height divided by 3, the whole thing multiplied by pi. Good luck. I hope this was helpful.